Financial modeling, topic 21, capital budgeting, section 5. We're going to perform sensitivity analysis of an investment. So, sensitivity analysis allows you to consider more than what is expected to happen. Sensitivity analysis includes the assessment of pessimistic, expected, and optimistic scenarios, hypothetical and historical scenarios, break-even analysis, and data tables. So we'll do this an example I got from that corporate finance textbook in the reference. And this is an airplane manufacturer considering the introduction of very low emissions hybrid jet engines. The engine's CapEx, OpEx, and market potential have already been analyzed by a cross-functional team. You examine its financial feasibility by building the following model and analyses. So here's your model. You develop a pessimistic, expected, and optimistic scenarios. So let's look at the expected scenario. You expect a market size of 10,000 engines. This engine will capture 30% of the market share. So it means they'll sell 33,000 engines per year at $2 million an engine, which has a variable cost of $1 million an engine, fixed cost of $1,791, and an initial investment today of $1,500. Discount rate is 15%, tax rate, depreciation 5 years, and no salvage. So the base case scenario is I have revenues of 6,000, variable cost, fixed cost, depreciation. There's my EBIT. Subtract out taxes, got my EBIT after taxes. Add back depreciation, I have my operational cash flows. I'll then look at my initial cost today of $1,500, and I'll calculate an NPV. And what I did here is actually I did a little shortcut in this example. I just did a present value of the discount rate here, 15%, for 5 years of C25, which is the operational cash flow, minus the initial cost. So I did a little shortcut there, took some liberties, but this example, what I really want to show you is the sensitivity analysis, so I just wanted to shorten up the example. So the NPV of the project really is minus the cost today and the present value of 5 years of getting this operational cash flow. And now if I took some pessimistic assumptions on every assumption and optimistic assumptions or values for every assumption, my pessimistic worst case is the NPV is negative 4,100, best case 26,000, and expected 1517. So that's one way of doing sensitivity analysis, is just do a pessimistic, optimistic, and expected value, and that gives me some more information to decide whether I really want to do it. Now the next thing we want to do is do some scenarios related to one variable at a time. Now these two scenarios here, pessimistic and optimistic, they change every variable in the downside, every variable in the upside. So it's really even hard to think about what's the probability of the optimistic scenario. Is everything going right or everything going wrong? A more reasonable way to do sensitivity analysis would be to build this table. Here's my expected NPV, always 1517. All right. Well, however, what if everything happens as expected, but I get a pessimistic market size? In other words, here's my NPV of 1517. What if only I got a pessimistic market size? Well, that NPV is negative 1802. I'm going to undo that, and I'll just type in here negative 1802. So that would be a scenario where everything's expected except the market size. What if there's a scenario that everything's expected except you have an optimistic market share? So again, I reset this. So if I've had an optimistic market share, I would replace this number with this one. I get a 5942, and I would just type that in right there. So this is a really nice table to look at. It tells me what are the really bad things that could happen to me that would make this project a negative NPV, and those would be reduction in the market size or the market share, nothing else kills the project. So it also gives me an idea of what things I maybe should investigate or invest in to ensure that these things don't happen. Maybe I put in my costs a little more advertising, and maybe my pessimistic market share will not be so bad, and then the only maybe thing I couldn't control would be the total market size. So that built a table that looks at one variable changing, not being the expected value. The other thing we can do is do hypothetical or scenarios, hypothetical or historical scenarios. So I did a scenario here. What if you're launching this project just when 9/11 happens and there's a reduction in air travel? Or at this point now, I'd replace this with a coronavirus, an example. So if that were to happen, I'd expect that they'd have changes in the market size. It's going to be smaller. And maybe for some reason, I'm a smaller company. I won't be able to compete with the bigger companies because the trust, and maybe I reduce my market share. And so for those reasons, if I think 9/11 or some other global reduction in air travel happens, my NPV turns out to be -2. Another pessimistic scenario is a hypothetical scenario. What if GE enters the market just when I do? Now that's probably going to expand the market, but my market share is going to really shrink, and therefore my NPV turns out to be 2,500. So what this forces me to do is think about what are the events that could happen that could derail this project, get a dollar amount to them, and then we need to think about what's really the likelihood of GE entering or having one of these events, and then think about whether it's still worth doing the project. We can do some break-even analysis. It's really interesting. It lets me know what is the critical value of some variables. That lets me know when the NPV goes to 0, or maybe when the IRR falls below the required rate. So how I could do that is if I wanted to see the break-even market size. Well, my expected market size is 10,000. But the question would be, if I go to data, what if, goal seek, let's set the base case NPV, that's this 1517, to a value of 0 by changing my base case market size. So what market size makes the project 0 NPV? Looks like it's 7715. I'll hit escape, and I would type in 7715. So you'd have to do that for each one of these variables, and you'd find out that my NPVs go to 0 with these levels of market size, share, and these others. So interesting analysis. What are the break-evens? And then lastly, let's do a couple data tables. So I've done one data table. Well, I've done one data table for you because we've done data tables like this before. I have a link to the base case NPV. I then would select this area, and I'm going to change variable cost per engine from 8.8 million to 1.5 million, and market size from 5 to 20,000. I would select this area, insert, or go to data table, where it said row variable, I would put in the base case variable cost. Where it said column, I would put in the base case market size, and I get this 2 variable data table. And we've done that before, so let me do one we haven't done before, a 1 variable data table, but it has more than one outcome. What if we want to see how market size affects a bunch of different outcomes, say revenue, EBIT, net income, free cash flow, and NPV? Notice I have links to base case revenue, base case EBIT, base case net income, base case free cash flow, and base case NPV. I can then select this area and hit data, what if, data table. Now I only have one variable that's in a column, so where it says column, I'm going to click, and I'm going to put in there the base case assumption for market size. And now I have the effect of market sizes of 5, 10, or 20,000 on 4 different 5 different outcomes. So in that case, we did a single variable with multiple outcomes versus one outcome with 2 variables. So there's my scenarios. Again, I'll do one more thing. An interesting way to do an NPV is have the NPV be a weighted average of several NPVs. So in this case, what if you just had these scenarios? It's either expected, optimistic, or pessimistic. These are the only things that happen. And you assign some probabilities. I think there's a 50% chance of this happening, 50% chance of optimistic, and 50% chance of pessimistic. Well, to calculate an NPV in that case, I could simply calculate the NPV as a weighted average. I could take 50% of 1517 plus 25% of 26,000 plus 25% of negative 4,000, and that could be my project NPV. So I could just build a little area here with some probabilities and calculate the true NPV of the project, including the scenarios. So in this topic, we'd perform sensitivity analysis of an investment.